Today on The Future of Everything, the future of stress and your mind. Well, 2020 has been, without a doubt, one of the most stressful periods for humanity in any kind of recent memory. We've had COVID-19, we've had social unrest, we've had political discord, economic tumult. Health, safety, security risks immediately impacting millions of people. And guess what? This leads to stress. There are many ways to experience stress, and it impacts all your senses: hearing, touch, smell, and most definitely vision. Ever since humans were living in small bands, combating predators and running away from them, they have developed a keen sense of their environment. That's why we have our senses. It was critical for their survival to perceive threats and respond. Now, this innate wired system for sensing threats and responding remains, even as our need to combat predators on a daily basis is reduced. You know, I've been sitting at the same desk for 6 months now, and there's just not been a lot of predators. Nonetheless, these sensory systems, in particular the visual system, plays a huge role in our perception of the world, how we process it, and ultimately how our minds and our bodies determine the levels of anxiety versus calm that is appropriate for us. Professor Andrew Huberman is a professor of neurobiology and ophthalmology at Stanford University. He studies how the brain works, how it can be repaired, and has a special focus on the visual system. He has studied how the visual system recognizes stressful or threatening situations and how the brain then goes on to process these signals and figure out how to respond. Andrew, I think most of us can understand how a visual threat like a lion running at us would be triggered by our visual system and lead to a response. But you have found that the vision system may be involved in much more subtle ways in detecting and responding to situations that are perhaps much less immediately dangerous. Can you tell me about that? And thanks for being here.
Well, delighted to be here. The visual system is really interesting in terms of the senses and how it interacts with the thing that we call stress. I should just, right off the bat, I should mention that, you know, the distinction between stress, anxiety, fear, and trauma, there's a lot of overlap between those.
Yes.
So just to define our terms, you know, you can't have fear without stress and anxiety, but you can have anxiety and stress without fear. You don't necessarily have trauma. So I'm going to refer to stress as a sort of catch-all for daily stress, long-term stress, short stress. I'll try and distinguish between the various types of stress as we go forward, but just to make that clear at the outset.
Great, yes.
To avoid any confusion. So a couple things about the visual system. We all think about vision as for seeing, and of course we see with our eyes, but we forget often that the eyes, in particular the neural retina, which is these three layers of cells at the back of the eye, are actually part of the brain. They're the only part of the brain that's outside the skull. They're literally part of the central nervous system. And there's a genetic program that pushed them out of the skull around the end of the first trimester of life. And you might ask, well, why would the brain put a piece of itself outside the skull? And it's because by being able to look at light energy, photons, from afar, we place our whole body, because our brain and nervous system control our body, in a much better position to respond to things in our environment without having to interact with them directly through touch. Other animals are more dependent on smell. Humans are very strongly visual dependent. Now, we also do this with our hearing, of course, but vision is the dominant sense that humans use to navigate the world and survive. And there are very interesting interactions between how we see and how we feel internally, stress, and as well as how stress impacts the visual system. So it's bidirectional. So for instance, let's say I'm moving through my morning and I make a cup of coffee, and then all of a sudden I hear something on the radio, or I look at my phone and I get a troubling text message, something really alarming to me. It could be about a family member, it could be about a world event. The stress response—
Plenty of these in the last 7 months.
Right. I think we're all familiar with getting these on a daily basis, many times per day. All of a sudden, everything has changed. And we normally think of the heart rate quickens, breathing quickens, we perspire, you know, the stress response, the so-called fight or flight response. But one of the most powerful things that happens to us that we don't realize because it happens subconsciously is our pupils dilate. And there's actually a change in the optics of the eye, movement of the lens and so forth, that brings that text message or that thing that we're even hearing it brings it into sharper relief. We see it more clearly, and everything else kind of fades away. And it's not a purely cognitive thing. This is actually like changing your phone's camera to portrait mode. If you've ever taken portrait mode, one thing is in very bold relief and everything else is kind of blurry in the background.
So let me ask you,
so that's what happens to our vision.
Will that response happen even if the initial insult was not through the visual system? So what I'm asking is, I get a text, that's a fundamentally visual experience, but I hear something on the radio that's equally stressful. Am I still going to get that visual change?
Yes. And it's because the stress response deploys a huge number of things in the brain and body. I won't list them all, but just to kind of capture the essence of it, there are two signals that run in parallel for the aficionados, one from the hypothalamus, one from the amygdala.
Parts of the brain.
Parts of the brain, that to a set of neurons that runs from about your clavicles down to your belly button. And all those neurons deploy neurotransmitter, they dump chemicals into the body all at once. Actually, the reason this system is called the sympathetic nervous system is not because it makes you feel sympathetic in the emotional sense. It's because sympa means together. And all of those neurons act together as a chain, and they deploy these chemicals into the body. The adrenal glands, which sit right above your kidneys in your lower back, they deploy adrenaline, also called epinephrine. Your brainstem deploys epinephrine, and all of that epinephrine and acetylcholine and other things create these responses in the body, like the quickened heart rate and breathing, et cetera, and the dilation of the pupils and the change of the optics, all subconsciously and all within 500 milliseconds, half a second.
Okay.
Meaning it's going to be very hard to prevent the stress response from happening. And as we go along, we could talk about some of the tools perhaps that my lab and other labs are developing to learn to push back on the stress response almost as quickly as it engages. But I mention that because I think a lot of people feel this kind of what I call meta stress. They feel stressed that they're stressed, and they feel like, oh, well, I'm doing my meditation and I'm sleeping well, I'm eating well. And why am I so stressed? Well, you're stressed because this system was designed to be very fast, half a second, recruit almost all of your being, mind, body, eyes, everything. And fundamentally, it was designed to agitate you so that you move. It was designed to move you from one location to another.
Physical movement, like let's run, let's reposition. So that's interesting, because you made a comment a moment ago that indicated that these responses may not be the best thing for you to be having. On the other hand, it's how we've evolved, and it's part of our system. So tell me, how should I think about this? You've described this great sympathetic reaction. I get my text message. Is that reaction going to help me do a better job at triaging whatever the situation is that I just heard about? Or is it actually more of a hindrance to the appropriate response and something that I need to combat? You kind of made a reference that we might want to suppress it or combat it. And I was wondering, well, maybe this is part of how I'm going to have a good, successful day dealing with life.
Yeah, great questions. So the stress response was, first of all, was designed to be generic. We often hear, oh, this was designed to keep us safe from large predators, and it was, but it was also designed to allow us to process information of any kind very quickly, to bring our focus to that information and deal with it. So the ways in which stress serves us adaptively is two ways. First of all, this change in the optics of the eyes, and it also even happens with our hearing. We sort of get a tunnel vision. We also get tunnel hearing for the thing that is most important. All of that was designed to do a couple things. But one of the more interesting ones that isn't discussed very often is the relationship to how we process time. What happens when that stress response occurs is that we start fine slicing time. It's as if we have a metronome inside of us that normally, if we're very relaxed, is going tick, tock, but all of a sudden it's more units per unit time, for overall unit time. So tick,
yes,
tick,
and
tick,
people have
tick,
described this like time slowed down or stuff like that.
Yes.
Or time sped up.
Right. So, and then we can get right to that because I think it's one of the more interesting features. But I'll just say that three things happen that are very useful about when stress occurs. First of all, we start slicing time more finely, which, as I'll describe in a moment, gives you more control over your external environment, not less. Second of all, and a lot of people don't know this, but the stress response deploys the immune response. In the short term, nerve fibers that connect to the organs of the body that deploy killer cells those liberate killer cells to combat infections. And so we always think about how stress makes us sick. Actually, if you've ever worked for a long period of time or studied for finals or taking care of a loved one, go, 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 and then you rest, it's during the immediate rest that you crash. And it's because the sympathetic nervous system also controls the immune response. It actually makes you less susceptible to bacterial and viral infections in the short term. In the long term, once the system moves from the acute stress response of adrenaline to more of a cortisol response, which kind of sits in the deep layers of the adrenals, and that's when you start running into immune compromised situations. So it helps us in the short term. And the third thing that it does is it really heightens all our senses. It really, the whole prick up our ears kind of thing, it really allows us to process information, not just more finely in time, but also in space. And so that's powerful. Now,
Yes.
what you mentioned in terms of time slows down, there's a theory out there, and my lab's studying this, and so this is still preliminary, but it makes a lot of sense that if our internal metronome, our level of stress is high, and the external world, let's say you're in line at the airport, well, we used to go to airports, but something is,
Those?
So you're late for your plane or to pick up your child or a spouse or something like that, and you're stressed, it seems like things outside you are moving more slowly. And it's because your internal metronome is not matched by your perception of what's happening in the outside world. That's why we believe, and this is work that I'm doing with David Spiegel's lab in psychiatry as well, we believe that the perception, for instance, in extreme traumas, extreme stress, that time slows down, like in a car crash, and you actually see events moving very slowly, is because your internal metronome, the stress response is so high that everything outside you perceptually seems to be moving more slowly.
It's like you're getting more frames per second, and it's like super slow-mo.
Right. And when we hear slow-mo, we think of longer time bits, but as you said, it's more frames per second. Take the opposite, which is the kind of more chronic stress response. When we're overwhelmed and exhausted, we get up, we look at our phone, we sit, and the world just seems like it's going extremely fast. And that's because our internal state isn't matched to that. I always say, I'm a pretty high energy guy. I love New York City. I get off the subway in New York City and I feel like finally calm, because I feel like the pace of things around me is finally matched to the chaos in my mind. Some of you may be able to relate to this. Some of you more mellow types might feel like, why is everybody rushing about? What's the hurry? So we all have differences in our kind of baseline, what's called autonomic arousal. And that brings me to the other side of the coin with stress, which is, I believe, and a lot of the effort of my lab is focused around how to teach people, well, first to discover tools, but how to teach people to recognize that this system that we call the autonomic nervous system, the one that brings us from sympathetic arousal of stress to what's called parasympathetic, which is really just because the neurons that control it are in the neck and in the pelvis. They are para around the sympathetic chain neurons.
Yeah.
So the parasympathetic neurons are associated with rest and digest. And typically the way people calm themselves with these is, well, first of all, it's never autonomic because it's just very indirect. The most common way that we've learned to turn off the stress response, but is very slow, is to ingest food, carbohydrates. And in particular, the distension of the belly, because of the vagus nerve is the 10th cranial nerve called the vagus nerve is a big part of this. When our belly is distended, it sends a signal to the brain that counters the stress response. And this is the essence of the parasympathetic response. Now, the fact that food can do that, or for instance, slowing our breathing, just merely shifting to nasal breathing, slowing our breathing. There's a beautiful book that was written by our colleagues, Paul Ehrlich, Sandra Kahn, called Jaws, which is really about the benefits of nasal breathing versus mouth breathing. The introduction was written by another colleague, Bob Sapolsky. When we shift to nasal breathing and we slow our breathing, we naturally engage the parasympathetic response because of the way that the diaphragm, this muscle in our body, is linked to some of the other circuitry in the brain that controls stress. So all of this is to say that the stress response is good. It allows us to react. It liberates the immune system. It does all these things in the short term. But I think everybody, starting from a very young age and until our last days of life, could benefit from having tools that allow us to push back on that stress response when we're not able to process information in the way that is most adaptive, whatever that situation is.
This is The Future of Everything. I'm Russ Altman. I'm speaking with Professor Andrew Huberman about our stress responses and ways that we can learn to modulate it. And I did want to get into two ideas, both really compelling, but you have started to deploy interesting technologies, I think, in pursuit of these ideas of training people to kind of sense their levels of stress or not stress and adjust them. And can you tell us about some of the more kind of avant-garde technologies that you guys are using?
Sure. So my lab, we work on mice and we do studies on mice and we try and identify brain areas that are involved in the kind of things that I've been talking about up until now. We also have a human lab. And I should mention that the work that I'm about to describe is done in close collaboration with David Spiegel, who's the Associate Chair of Psychiatry at Stanford, world expert in medical hypnosis.
He hypnotized me once. We can talk about that on another show, but I had a fear of planes that he wiped out with his hypnotism.
Hypnotism gets an interesting and kind of bad rap from the stage hypnosis world of like swinging pendants and things. Yeah. But David has brought the medical hypnosis technology to a whole nother level. And it's really interesting because hypnosis invokes the visual system in some very powerful ways and the respiration system. So the work in my lab and the work with David has been focused on a couple things. But the thing we did about 4 years ago, people in my lab were studying fear and stress in mice. But of course, we could ask the mice what they're feeling, but if they tell us, we don't understand. And they probably don't understand what we're saying. So we shifted to humans. And so we have a lab where people come in, they do virtual reality, which is
like the goggles,
like the goggles. Very in-depth, what our other colleague, Jeremy Bailenson, Communications, has really built up over a decade or more, this idea of creating presence in the VR. You know, people know it's not real when they put the goggles on. If you come into my lab, you might put on those goggles and swim with great white sharks or give a public lecture or be in a claustrophobic environment or a heights experience. And of course, at first you realize that you're not underwater with sharks, but there's something about the sensory inputs when you start to combine vision and hearing in very robust ways that you get what Jeremy has described as presence, where the nervous system flips into these states where it actually thinks it's in that environment. So we put people into these environments. We do a number of different things. We record from a lot of areas in the body. So we were recording, for instance, I mentioned the eyes are part of the brain, not the body, but we're measuring pupil size changes to measure these changes in autonomic arousal, which is the fastest readout of the stress response that we can get from the periphery. We're looking at things like respiration, heart rate, et cetera. And so we're trying to get a signature of the stress response. In some people, because we have access to neurosurgery patients, we have people come do this who have electrodes embedded in the fear centers of the brain. So we're getting recordings, what are called local field potentials. So a lot of different action potential activity, electrical activity from neurons in the amygdala, in the insula, in the orbitofrontal cortex, from all over the brain while they're in these equivalent experiences. So we do both kinds of things. And then what we've done is we've found some very robust readouts of the stress response. And we do this in people also, I should mention, that have generalized anxiety versus what we call typicals, although everyone, anxiety and stress, of course, is normal. So what we found, I can just mention a couple highlights that we found, and then I can talk about some of the interventions that we've developed based on those findings. First of all, and this is a manuscript that should soon be out, we found that there's a particular pattern of visual search that people who have generalized anxiety invoke when they're in an environment that they don't understand or that makes them stressed.
Literally mean the way their eyeballs are moving around, scanning the environment is different.
That's right. It's more what we call saccades, so more eye movements. That probably doesn't surprise people. But we controlled for this very carefully by putting them in equivalent environments where only a few select experiences were missing. So we can control for things like luminance, and we can control for depth in the environment and these kinds of things you could only do in VR. You couldn't do this in it. I couldn't imagine doing it in any kind of other experiment. It's also based on the velocity of those eye movements. Mm-hmm. So this again just speaks to how closely tied the visual system is to the stress system. And then we've identified particular patterns of breathing associated with the stress response, as well as patterns of breathing that are associated with people's attempt to calm themselves. And that's where it starts to get interesting, because work from yet another colleague of ours, so blessed, right, to be at Stanford. This work really, I'm not biased towards Stanford in this discussion at all, except for the fact that, you know, this work really was done there by not my group, but Mark Krasnow's group in genetics, and it was in collaboration with Jack Feldman at UCLA. They discovered a particular class of neurons in the brainstem that control what are called physiological size. You do these in sleep.
Sighs, S-I-G-H-S.
S-I-G-H-S. You do these in sleep, and you do these in claustrophobic environments subconsciously. Animals do this before they go down for a nap. And it's a pattern of breathing in which there's 2 inhales followed by an extended exhale. And typically the inhales are through the nose and the exhale is through the mouth. This is not a breathing technique we invented. This is a breathing technique that evolution and Mother Nature invented. And what it does is very interesting. You have the 2 big lungs, but you have all these little sacs of air in the lungs, which increases the volume of air that you can bring in. Those sacs collapse over time. And as a result, oxygen levels start to go down and carbon dioxide levels go up in the bloodstream and body. And that is a big part of the signaling of the stress response. In fact, we breathe because carbon dioxide gets too high and neurons sense that carbon dioxide. So what happens is these little sacs deflate. And a physiological side, the double inhale, is like if you've ever been to a party, a kid's birthday party, you're trying to blow up a balloon, you blow once and it doesn't inflate, you blow twice. And it pops open. Right. And it doesn't explode, but it pops open, and then you can inflate it the rest of the way. So physiological sighs expand the alveoli of the lungs, allow oxygen back in, and allow you to offload more carbon dioxide in the long sigh.
That's
people do this. Yeah, it's really cool. And we all do this, and animals do this. Now humans, there's been a lot of discussion in the last 2,000 years about how to calm the self. There's a lot of interest in meditation and mindfulness practices, which of course always incorporate some breathing. If people do yoga or they go for a run, there's all sorts of activities that we associate with stress relief. One of the things that David Spiegel and I decided to ask was, well, what role are specific patterns of breathing playing in this? And can people export those spontaneous patterns of breathing to deliberate practices that allow them to push back on stress at any point? So
before we get to that, I just want to say that this is the future of everything. I'm Russ Altman, and we're going to return in a moment to find out how your breathing can affect and impact your stress levels on SiriusXM. Welcome back to the future of everything. I'm Russ Altman. I'm speaking with Andrew Huberman, and we were just discussing how there are all these through the virtual reality experiments that you and your colleagues have done, you've discovered all of these natural behaviors about breathing, eye motions, many different things that are both signal the onset and also may modulate the level of stress in a human. And you were just getting to this idea that we might be able to harness that for a more intentional manipulation of our stress levels. So what did you learn, and what did you find?
Yeah, so we discovered that there are 2 main features of the attempt to calm oneself response. Let's call it that. And these again are features that were built into our neurology and the connections between the brain and the body. Physiological sighs, that double inhale followed by an extended exhale, done just 1 or 3 times, seems to be nature's way of taking that sympathetic stress response and balancing it with a more parasympathetic relaxing response. The advice we hear out in the world, take a deep breath. Turns out that's not quite right. It's take 2 breaths, ideally through the nose, and then just exhale. That's not quite right because the exhale has to follow the 2 deep breaths. So what David Spiegel and I have done is we've set up a very large experiment now, which because of COVID and the situation with the pandemic, it makes it challenging to bring people to the lab. The timing couldn't have been better. What we did is we knew there was a lot of stress in the world. We partnered with a company that makes, and I should say that they donated, and we didn't partner in a formal sense, but they donated wristbands that measure heart rate variability, respiration, sleep quality, sleep depth, duration, and so forth. And we have now 125 people out there in the world who on a daily basis are incorporating 1 of 4 different kinds of breathing protocols. And we're examining in a hypothesis-driven way how it affects their stress, their sleep, their heart rate variability. Heart rate variability being good, by the way. You don't want your heart rate very high or very low throughout the day. You want variability. A lot of people overlook that. They think, oh, you're supposed to always be 50 beats per minute or something. We can get back to the relationship between breathing and heart rate variability later. But the 4 conditions that we're exploring are 1, physiological sighs. The other one is a dedicated 5-minute breath, or you could call it breath work practice, which is called super oxygenated breathing, where people breathe very intensely, 25 or 30 deep breaths. It always looks funny to breathe on camera, but I'll do it anyway. So I'm breathing in through my nose and then out through my mouth very vigorously. By the end of that 25 or 30 breaths, you feel agitated. And the reason is it generates the sympathetic response. You're self-inducing the stress response. And you say, well, why would you want to do that? Well, it's immediately followed by a long exhale and then sitting as calmly as possible with adrenaline in the body. So it's a mild form of self-stress.
Yeah, it kind of rings a bell for some athletes right before their event. I mean, I'm imagining people may have discovered this on their own. I think it's possible because you think of these athletes like before a 100-yard dash doing these little breathing things, and maybe they figured this out.
Yeah, I'll just spell out the logic for looking at physiological size, a known approach for calming the self. The reason for looking at those is it's what I call a real-time tool. You know, it's wonderful to have breathwork practices, exercise, meditation, baths, massages, vacations, but we wanted to develop tools that people could use in the moment. Right. And this comes from a well-known feature of psychiatry, which is even for people who have panic attack who are prescribed, Valium or something, they feel great relief by knowing they even have it in their pocket, right? And as well as the ability, you don't want to have to necessarily put yourself into a state, go off and excuse yourself during a stressful event. Sometimes mid-airport line, mid-public lecture, mid-argument, mid-troubling text message, driving, you want to be able to calm yourself. You can't do breath work. Right. You got kids in the car, life's happening. So this double inhale exhale was designed as a real-time tool to invoke calm in a self-directed way and to do it through neural circuits. It's not just about the lungs, the diaphragm, and carbon dioxide and oxygen. It doesn't require sitting in the lotus position or anything or lying down. It's about capturing the neural circuits of the brainstem that were designed to induce the parasympathetic calming response. The superoxygenation work was designed by us and by others to explore whether or not people could raise their threshold for what we would call a stress response. So by inducing adrenaline in the body at a low level and self-inducing it, but then remaining calm cognitively, you can potentially get your hands around this feeling that is normally so agitating that it troubles you, that you're comfortable there. And again, this comes from a statement that David Spiegel made, which is, when it comes to stress and trauma, it's not just about the state that you end up in, it's how you got there and whether or not you had anything to do with it, right? Yeah. When someone else or something else triggers your stress, it's different. So we're exploring that. We're also exploring a pattern of breathing called box breathing, where you inhale for about 3 seconds, hold your breath for about 3 seconds, exhale for about 3 seconds, and then hold your breath after that exhale for about 3 seconds, and then repeat. And it's a very unusual pattern of breathing, one that we almost certainly never do spontaneously, but it increases what's called our carbon dioxide tolerance, which is our ability to tolerate these low oxygen states. It's actually the one that freedivers use.
I was just going to say, the guys holding the boulders underwater do this.
Right. Something I do not recommend, as I have some friends who are expert freedivers, but even they would say there are only 2 ways out of that sport. One is to resurface alive and the other is to resurface dead. Please don't. But box breathing is something, all these you do on land, not near water. And I should just mention, over time, what we have people do is extend the duration of those inhale holds, exhale holds. And people, freedivers and people who learn carbon dioxide tolerance can, over a series of days, can start to extend those inhales to 8 seconds in, 8 seconds hold, 8-second exhale, 8-second hold. That's actually very challenging. Now, what we're finding, and these findings are preliminary, are that people are seeing great improvements in, and again, preliminary, in depth and quality of sleep, ability to fall and stay asleep, ability to counter stress throughout the day, feelings of control at a subjective level over life in general and their life and their sort of, their agency in life. And
I'm afraid we're going to have to stop there just for time, but this is unbelievable. Sure. The ability to manipulate these stress responses with breathing is something we need to learn more about. And I want to thank you. I want to thank you all for listening to The Future of Everything. I'm Russ Altman. If you missed any of this episode, listen anytime on demand with the SiriusXM app.